चेक कर लेता हूँ वही साथ। हाँ अभी चेक कर लेते, चेक करने को जरूरत नहीं है, जब सर आएंगे तभी चेक कर लेंगे ना, अभी 5 मिनट बाकी तब कर लेते हैं ना।
हेलो। हेलो टेस्टिंग। हेलो। आ रहे ना? छोड़ दो।
हाँ अभी वो अभी
हेलो।
सो वेलकम फ्रेंड्स, ये हमारा जो सुपरनेशन टॉक सीरीज चल रहा है उसका थर्ड टॉक है। दो टॉक आपने सुनी और काफ़ी अच्छा लोगों ने अपने एक्सपीरियंसेस बताए, काफ़ी अच्छा उनका अनुभव रहा। तो उसी सीरीज़ में आज ये टॉक अरुण का टॉक है। फिर मैंने वही ये इंग्लिश टू हिंदी करने वाला प्रॉब्लम अभी चल रहा है। अभी जब शुरू हुआ था तो मुझे संध्या की हेल्प चाहिए थी, तो मैंने उसको बोला कि आप इसको हिंदी सेक्शन के साथ ऐड कर लो, हम लोग इसको हिंदी में भी थोड़ा थोड़ा बोलेंगे। अभी 2 दिन सुनने के बाद मैंने उसको बोला संध्या इसका हिंदी कर दो, तो बोला मुझे हिंदी करनी नहीं है, मुझे इस टॉक को हिंदी में इंक्लूड ही नहीं करना है। बोले आप लोग पूरा टॉक इंग्लिश में देते हो, फिर मेरे को बोले इसे हिंदी में इंक्लूड कर लो, मुझे ये काम सब नहीं करना है। तो एनीवे कल जैसे देश पांडे साहब का भी टाइटल काफ़ी थोड़ा मतलब हैवी था, तो, तो मैं सोच रहा था कि इसका हिंदी कैसे, तो एक मेरे पड़ोस बैठा उसने मेरे को बहुत अच्छा आइडिया दिया, बोला गूगल कर लो यार, सब पता चल जाएगा। तो अगर आप किसी वर्ड का मीनिंग नहीं आता है तो आप गूगल करके देख सकते हो। तो मैं रिक्वेस्ट करूँ जो का पार्ट मैं रिक्वेस्ट करूँगा अरुण से कि वो अपना टॉक चालू करें। धन्यवाद।
Hello. And there is no echo, right? I think I get it. शुक्रिया राज, शुरू तो करे ऐसे ही तसल्ली तुम्हारे तसल्ली मेरी। ऐसा नहीं कि मुझे हिंदी में देना टॉक देना पसंद नहीं था, बिल्कुल था पसंद, बट जो हमारे जो ये टर्मिनोलॉजी वो उसे हिंदी में रूपांतर ट्रांसलेट करना मज़ा नहीं आया, इसीलिए। एंड थैंक यू मैडम गेटिंग दिस इनिशिएटिव ऑफ हैविंग दिस टॉक। इस प्लेटफॉर्म में मैं कई बार मतलब ऐसे टॉक्स किए, एंड ऑब्वियसली दिस वुड बी ये आखिरी होंगे इन दिस फ्रेमवर्क। एंड देयर आर मैंने बहुत सारे यादें आते हैं, बट सबसे बड़ी चीज़ ये है कि 1991 की मार्च, 2004 के दिसंबर, square meter is the same of the seminar hall. There was a wish कि this could have been perhaps because we have हम लोग खुद 100 या उससे कम in 1991 आप लोग थे and today हम 600 plus, but we haven't. इसकी कोई और connotation है नहीं कि मैं ये अपने progress के साथ कुछ और जोड़ के बोलूँ, but I think now to begin my way of capturing the snippets of this 3+ decades that I have been in this organization, and I say that it indeed embeds an everlasting aura, and I mean it. I mean it, and I would be living with it, of course, but in the course of what I would be conveying, there would be several aspects which would be written, which should possibly generate a feel of some different kind to some individuals. There is never ever any intent to have any personified comments, but excepting when there are really appropriate ones that I could claim. And there would be certain aspects which I would be speaking, which I didn't want to write down, because this is on the YouTube, and this will be, I'm absolutely okay with the YouTube to be on the web, because the contents have been, I mean, if there is certain things which you still find that should not be, I can remove, but it would be good to have it on the web. I joined this organization in 1991, 12th of March. And as I joined this organization, I joined from where? I joined from IIT Kanpur. I just completed the master's in the nuclear engineering. And incidentally, how much time do I really, because I will then space and present it from the perspective, honestly. Max? Okay. I'll try to do it by 3:50, if it is bearable by, gathering here. But before doing the master's in the nuclear engineering, I was in the post-MSc associateship of Shah Institute of Nuclear Physics. And for some of us, or many of us who would know, that's a reasonably difficult one to get in, but that essentially takes you to the PhD in Shah Institute of Nuclear Physics. Again, meaning no offense to all, the 1 year of stay in the SINP campus and doing things, I decided to myself, I will not do a PhD in this field. And I seriously wanted to shift up. I went to Shah Institute after working as a management trainee immediately after my MSc days in Bata, India. Nobody knows this perhaps here. That was a Challenge 2000 training, wherein you get recruited on a super competitive basis all over India. But, and I was one of those 14 people who were there. I didn't like it there as well. I was into the production, I was in Patna. I didn't like it. I shifted to Shah. And after that, when I had a reasonably very good score in it, and I had material science and nuclear engineering, I chose nuclear engineering as the option. And after doing that, practically I had enrolled, because there was December we completed, and this interview was there, I don't remember, it was in January 6, 7 or something like that, of 1991. And then there was a span of time, and I had enrolled into the PhD program in IIT Kanpur, and there I had found some reasonable personnel with whom I could, see that yes, the progression could be fine. And indeed, when I was coming over to ITR, there were requests that I reconsider the possibility of staying back there and completing. Professor Wagmare was one of them, and I think there were many others, but that was the IIT Kanpur part of it. The 1.5 years in IIT Kanpur provided me a kind of an exposure of a very different kind, which I think I could encapsulate in a very different framework. But that's for a memoir to be written if at all. The interview in ITR was very, very interesting. When I came here, obviously it's a competition and people are all stressed up. I was not so stressed. So I asked about the project work, etc. But what was very wonderful at that time of the interview committee is that after having the interview, they asked me, would you like to see our facility? I said, yes, of course. And then they called Professor Jha, and it was Jha, and his lucid way of explaining, he took me to the Aditya Hall, and the way he explained the whole machine opened up a kind of vista, and I was really hoping that I get to come over, because I didn't know. Though, Professor John, during the interview, he said, but you would not be a nuclear engineer if you are coming here. I said, sir, it doesn't matter, as long as I am doing something which is very interesting for me. I care less about the tagline of what it is. And so I was here. Later, I think, and those days the decision making was really quick, possibly, and I got the offer, I came here in March, and then a very interesting anecdote here. I come here and I go to admin, formalities done, they take me to J.D. Patel. J.D. Patel takes me to Professor John. Yes, I know you would be here and this is all fine. J.D., can you take him to Professor Mattu? Perfect. So I go along with J.D. to Professor Mattu, and Professor Mattu's door opens, and J.D., sir, I have come, I wanted to introduce you. Professor John has sent me to introduce this person. Professor Mattu said, for what? That was the first interaction I had with him. And then he said, there's this, and later I got to know that this position was essentially, Professor John had expressed a wish to take his license, but then after the interviews and also between Professor John and Professor Mattu, they had discussed maybe some experiments. They do discuss many of these things. So they decided that why don't you take him up and try out your thoughts. So that was the early phase, which is in 1991 to 95, I would say. 1995 to 2005 was an intermediate, and then, so see, the outline is just there. I will then dwell with some of the early phase induction and learnings. The SST-1, which I consider is a very important mission by this organization. The ITER project association of ours even asked some questions of the relevant kind to ourselves. I would have some notes for the young professionals, and maybe some of them you will find it very straight, very obvious, but some of them are very important. For me, what was gratifying is I think I would like to really make a note of. What do I leave behind is also something which I would like to make a mention of. But here, I would like to say that as we move into SST-1, you will see me digressing into neutral beams. And this also will take a course onto the ITER. So the flow is this, but this is how it is. Now, coming to the part of the introduction. So I was inducted into this diagnostic group that was of Aditya, and the leader was Professor Mattu. And I must say that at that point of time, the reservations or the unavailability of accommodations was not so stringent. So I was fortunate to have scientist SCs recruited then when, I mean, they were kind of temporarily given accommodation if they asked for in the AES hostel. And nowadays it doesn't happen in the SC, but I think the TTPs and others is a completely different case. There, I think that was one very important aspect, I would say, that I was fortunate to have this accommodation because it enabled me to understand who all are there. Students were there. Shishir was there. I think little Naina was also around in those days. And I used to see Shashank a lot. There were many, many others. You, I remember very well, and so many others. This actually kind of made me understand that this is one part of the organization which is of a certain kind, and I kind of, imbibe the perceptions. Then for the work, the discussions begin and all that. So SKM, I would say, he asked me to look into the accelerators for the plasmas and their applications. And he brought out a very interesting proposal was that the Aditya or any Tokamak diagnostics in the edge, you have this laser blow-off which goes at a moderate energy, few EVs. And if we could essentially push this beam higher energy, then the penetration would improve. And if the penetration improves, it essentially gives us a better diagnostics beyond the sol edge and also into the intermediate region, thereby for this kind of tokamak. And maybe this thought was because this tokamak, Aditya, is primarily into the edge studies is one of the focus at that point of time. So could we do this kind of an acceleration which is possible? So he also suggested look into some of these, and then these different plasma guns. So washer gun is one of those concepts which finally I adopted, and configured a scheme and initiated an experimental plan. Worked out a staged approach on how to go about the experiment. In terms of this is today when I do things of other kind, and when I think what was really done, I would say that this was really amazing. Reasonably experimental arrangements were made ready within around 9 months, initiated experiments early into 1992, and obtained results by 1993, put it into RSI, got it reviewed, and January 1994, we had the first publication. So this was very interesting. But here goes the point which I wanted to make. This is an experiment where we had lasers, we had high voltage power supply systems of the pulse kind, we had plethora of vacuum, we had spectroscopic diagnostics, we had data acquisition control, whatever in that kind of forms used to be. We had some fabrication works related to this, We had feed-throughs of different kinds, and particularly the high voltage electrical feed-throughs to power them. We had the laser to be aligned and to be placed. And we also had these kind of targets where you are supposed to basically have this glow. And to do this characterization, before bringing the laser on, I developed, this was kind of a discussion and position, what is called these electromagnetic gas guns, which are pulse. You give a pulse and then you start getting the gas on a pulse mode, and then you do this. Yesterday, she was showing a paper, neutral plasma interaction by Venkatramani and Nathu. That had that gun concept, and then I adopted it. No. The purpose is not to discuss that. The purpose is that when I went into this experiment, and kind of, yes, Ajay was there as a part of it, Ajay Kumar, but it was like you are accountable, you are responsible. In the next slide, you will see what I have perceived out of it. But you have a domain where I did not have any experience on high voltage engineering, nothing on vacuum, some on the data acquisition because I was doing what is positron annihilation spectroscopy in my MTech thesis work with Professor Singru and Kulkarni, and Kulkarni is not there anymore. Lasers, yes, I used, but not this class of laser. This was a pulse, 1.5 joule ruby laser, very, very high energy. Nothing. So this was like an opportunity to sink into every aspect of different disciplines, electrical, diagnostics part of the physics, some part of the mechanical manufacturing, lasers, and whatnot. So it essentially allowed me a good amount of, reaching out with substance. This is where Professor Mathu really provided a wonderful kind of a guidance. When I showed him, this was erected very fast. When I showed him the pulses that comes out of this, he asked me, did you see the nature of the pulses? Did you see the ringing in them? I said, yes, of course. Do you know why they come? I said, these are from this equation which is there. Did you solve them? No, I did not solve them. Should you not solve them, and should you not get the kind of, wave patterns that you have? And I really did it. I did it, and I saw that what is the excitement you get when you do some model, do some experiment, see the results, and that also aided me in characterizing the kind of damping resistors, etc., which are there. So it was kind of a comprehensive understanding gathering. This has been, or had been, and also is the merit of this organization. You can spread, you can actually do what you feel like doing within the domain of what you are doing, and you can learn, gather, enrich yourself, and also propagate. Now, propagate is something which is very important. I didn't know, as I said, many of these fields. I sincerely acknowledge Satya, Mohandas, Shankar, Lalit. In those days, he was into the diagnostics group. Ganesh Prasad, later, when I was doing some analysis. Then, unfortunately, we lost him, JP Singh, in the lasers. Of course, Govind Ajay was also part of it. Now, these things, and further, a very important understanding I have, and that is here. Professor Mathu suggested this, fine. So, in principle, he is the owner of the concept, this you can do. But then, as an implementer and as a learner, I did it. It's like a student, but I did it. When I did it, when it came to the paper, there is no way that he took his position as a last term. This is the learning I gathered. In fact, while I may be having, I think it's not a very bad H index if it is 20, but I may be having some reasonable number of publications. I don't even track my publications, maybe around 125, 130, I don't know. But plethora of them you will see me as the last one. Where it's because of this. I learned this, that when you really have this, when you are leading something, you don't put yourself first. Now that is one learning. The interesting work was the only comment that I got in that review and nothing else. And of course, anyone doing review in the AIP publications, If they see it from India, the English may have to be improved or maybe that would be a kind of a standing comment. That perspective. My learnings from there is never hesitate to exploit opportunities to learn, and this is the message. Never hesitate to seek guidance from personnel who have knowledge and experience, irrespective of positions. Scientists carrying out experiments need to have a student-like approach. This, I think, today is essential to be embedded. Possibly this is somewhere it has withered down, it is not, I don't see that. The organization enables independence in execution of assignment to the fullest. Exploration beyond mandate is encouraged when the frame is within the ambits of the experiment. And scientific discussions often aided broadening of horizons. A little bit of scientific discussions which I have participated in those days. Some of you may remember the intermittency in Tokamak, that paper. And here it was Chenna Reddy, there it was Jha and others, and they were kind of having a very animated debate. And the way it was, the way they really articulated both sides, their arguments and the defense, for an initiator, it is a very, very good learning. So then and here is another contrast. So after this was done, I was into the oven refurbishment, where I interfaced also with Vijay and Bharat Doshi. This was a project under Alika, who was supposed to have the lithium oven into the system. And somehow, because of some engineering issues, it was not working. So, again, SKM asked me, can you do this? Can you take up this and kind of integrate? We didn't go too far into this because by that time SST1 came up when it was into this, because it was 1995, I think. But here are certain experiences, because I did work in it to a reasonable extent. We did refurbish it to the extent that was asked for, but that was a mechanical one. This was the first instance where I went with, I think, Joshi to some of these Rajkot companies. And it opened up my horizon. I mean, what kind of amazing, those 30 years back, 34 years back, the competence in the industries in Rajkot. And that was the first. I mean, I didn't even see some of the industries here. I saw some of the workshop things here, but that's very different. That is one. Beyond that, I developed an understanding of the complexities that apply to tokenomics. Immense complexity even on a machine like Aditya. And in fact, smaller the machine, worse is the complexity. And well, I now, with ITER and all that, I realized that I have worked there and people work there even without a helmet. And how many times I have got this big swollen this thing on the head, because you just don't really take that. But that should be done. But the complexities was appreciated, and realized that access constraints, vacuum interfaces, and other protocols. This part is important. But this was a task taken by me. I think this part is important. That it was a task where I was not a part of the initial design. And when you do something which someone else is the originator, and unless you have a flow through which tells you what you have to really get to know, what you have to implement for, you are lost also sometimes. So this is important, but much more important realization, even at that stage, I think, that this organization, while all the accolades there, it has limited incorporation of engineering design and very limited roles of engineers in decision making at once. This was one observation which I embedded at that time. And I think I gathered this because I realized how the discussion can go. Now, well, I was a designated scientist, but really after this IIT exposure, that's why I said whatever I've encapsulated, I just realized that you have to break barriers. You cannot have a discipline specific and you cannot have an attitude specific. So that's what I captured, and I came with that kind of a rationale. So this perspective has witnessed certain progressive mitigation. But this mitigation, I would say, with ITER-India, when I talk of ITER-India, yes, there has been an absolute mitigation. Within ITER, I think it still is. Some of the things which I said I would definitely convey, but may or may not be, so conducive from the overall perspective. The SST-1 mission, here I think I'll stand here from there. Yes. This has been a mission to me, okay, it was in 1995. The mission started, and I think I will speak about my involvement soon in this. But this mission embedded aggressive integration of technologies and very ambitious physics objectives. No problem with that. Tokamak GPX, which was not made, that design basis was available, and that formed several important decision making in terms of the configuration and others, not on the size. The achievements, I think, personally have been very significant. The progress in cryogenics and RF systems as a standalone mode owes it to SST-1. Similarly, competence in manufacturing and installing operating superconducting magnets is a very important. Development in neutral beams is another important point to note, and that's where I actually have had a reasonably large part of it. Though one may be critical about the rate of progress. Gaps, however, have been there in implementing QA, QC, in principle, the earlier part, what I said, engineers' involvement in the decision making in some form, in major form, documentation, and most important, why there have been a difficulty and failure is, as I have captured, is the propagation of information of the right content to the senior management have never been confirmed. There have been instances where, I mean, you will see this later as a younger generation, the carpet has gone heavier and heavier with the brushes up. And the senior management have been kind of given a picture of a different kind. And this essentially led to the discussion. And I really should, I do not know, Raju was in IFRC, so I do not know if he's listening. I should really compliment him that he's trying to bring out all that needs to be spoken about this device, about this setup, about what has gone wrong. And we should be open. This is science, this is technology. Neutral beams. So SST-1 was configured to have around 40 kiloamperes of current drive with the neutral beams, and that calls for a power range, depending on the densities, of around half a megawatt to around 1.5 megawatts. And the energy range for the current drive was around 55 kV, and the tangency radius, which was around 98 centimeters, emerged as an appropriate system requirement. This last part of what it is, that is basically parameter fixation, this, of course, I did it, and I think I have next point itself. I sincerely owe it to Srinivas in terms of having, he essentially taught me how to operate the Baldur, fix parameters in it, and go through, and so many discussions I had in those days with him, and I really, I miss his presence, otherwise. But this was done. Now, the important point to note here is that of all that we did, we realized that to bring in neutral beams into the system, you would need something which is, do we not have a laser pointer of a physical kind? Because otherwise I'm not able to move. Do we have of a physical kind? It will not work, but at least it's okay, it is okay. I mean, because otherwise I have to just get back and the 20 centimeter access to the port to accommodate. In some of the discussions here around, in many of the SST reviews and otherwise also, we hear that the machine has gone big because of neutral beam. Well, it has been. But at that point of time, there was a discussion that have a port which is customized. Either one non-standard port, wide enough, or even bring out a tangency on the port configuration. It could be done with the spacing of the TF coils and taking many other aspects. It could be. I think there was a very clear decision from which is steered by the VV design team, that let us have the standard configuration. And the standard configuration essentially has led to the cost. It is not neutral beam which has determined. It has been the decision of a mixed kind which has gone. And so the vessel is big. But then the vessel is bigger, but that did not rule out the possibility of having a bigger plasma at a later point of time with moving out the stabilizers or maybe with the coil configuration. But that was not a part of the discussion that I was in. I was also not a part of the discussion wherein it was decided that 40 kiloamperes or so would be the typical mandated current drive. That was an early part of it. I came in when I was asked, can you look into it? Would you like to get into it? And things of that kind. So NB was mandated to have an ion source. How was the NB to be done? And the NB was supposed to have an ion source procured and remaining technologies developed in Indigenous. Power supplies and data acquisition was led by Ujjwal at a certain point of time, and mechanical systems by self as group leaders, and Professor Mattu was a project leader. Now, here again, Professor Mattu in 1995, somewhere middle or end of September, October, he went to Germany, KFA Jülich, for a certain period, and three of us worked on the systems. Nirmal was working on the ion source, Jana was working on the axle code and the accelerator and all that. And Professor Mattu then, he was working there, but he performed many of the calculations on the source, on the accelerator, on the pressures, basically on the transmission, etc. And today, then he used to send us notes through mail, surface mail. And those notes have been compiled by us. And I must say this, that the generation later, maybe 10 years later, 15 years later, and today's, if you get an opportunity, look into these notes. It is essentially a treasure. You would not see a reflection of passion, of involvement of the kind that was reflected in it. This was again something which we absorbed. Now, so in our approach because his close proximity, I think he took an approach that we take this decision of aligning mostly with the Textor system, and was fair enough, fine enough, because the energy ranges of the Textor Jülich system was also 55 kV, and everything is configured according to that, and we took this important approach to go about it in the way it is. Now, before I go further on this, for some of us, you must have heard about the neutral beams. And neutral beams essentially are particle beams, and they are, for those who are into it, please excuse me for the next 5 to 7 minutes. So they are essentially have metrics of energy, and that depends on the tokamak size and the plasma density. And you typically have 40 to 80, and you also have reactors, very high energy ranges, in the order of megavolts also, as you see in it. But that's a deuterium megavolt. So per AMU, it is fair enough to say 500 kV. Current you have, which is dependent on the duct configuration and fueling, and also needing what is the power, but 20 to 150 amperes is what you plow in. You put a power between about 1 to 2 watt per cc, and it is also dependent on the diverter's capacity. Species, you actually have hydrogen and primarily deuterium, but jet also use tritium. Some number of sources in the beam lines, if you are needing more power, because the positive ions go to a current density of 300 to 350 milliamperes per centimeter square on the ion extracted current. So they can essentially put in about 7 to 8 megawatts per source, or maybe 6 megawatts per source. And the neutral power, if you need, for example, jet lines, many of you would have seen 1, 2, 3, 4, 5, 6, 7, 8. That's because you put in about 2 into 8, 16, kind of 15, 16 megawatts per beam line. Make it 2, and you have what you need. And you have ion removal system, because why? Because you will see it in a couple of slides later. And these are essentially the basic calculations. The physics of the neutral beam, propagation, absorption into the tokamak. It goes by the cross sections. It goes by the mean free path that you have. And you get a formulation wherein the path that you need to have will have to have some kind of a good ratio to get a reasonably good power deposition profile. And depending on what your objectives are, if your objective is to have a current drive at the core, you better have that energy and have a current profile, which is going to be power deposition profile, which is going to be conducive to that. Typically A, the small radius, minor radius by the lambda is 2d3. Well, you have to also decide on the configuration of the beams. So as I said, the 55 kV or 80 kV per AMU, 80 kV, up to 80 kV, we take what is typically around positive ion beams, and beyond that, what you go for is negative ion beams. But we had, in the early days of my positive ion beams. And why beams? Why was it so exciting? PLT in 79 had first shown, and then quickly in 82, you had this H-mode demonstration. And all were essentially primarily enhanced or distributed by the beam. So beams became the in thing for any tokamak, and it is there also today. It is another matter that demos talk less about beams, primarily megavolt, negative ion, and the encapsulation of the real estate, which is the tritium building scheme. Otherwise, beams are not something which are to be kind of abstained from. The system, as I was saying, you have an ion source, you have a neutralizer, you have a neutralizer producing in the gas charge exchange method, ion source producing plasma, and ion extractor extracting this through the electrostatic acceleration, very precise accelerators. Some of them, if you see, I may not have too many photographs, but whatever I can convey, to the extent you can always see the systems here. They produce the ions. The ion beams moves through the neutralizer on a charge exchange mode, generates the neutrals, and the neutrals are then, and also it is not 100% neutralization, generates ions, also takes on board the ions. The ions are then removed by an ion removal system, which is magnet. Then you have a beam dump, or you open up the beam dump to go to the to send the beam to the tokamak, and you need neutrals in the tokamak because you cannot push an ion through the duct because it is a intense magnetic field. You will just load it on. Though inside the duct you do have the beam blocking as a phenomenon, which is a difference. That's a hardcore neutral beam. Let's not get into that. Here, I would say that when you see this, you see vacuum vessels, you see precision engineering, you see extreme ends of high-end, what you call thermal management. You have not seen here in terms of the integration of the source. These are operated at 55 kV, so there is an extreme high voltage, which is at a multi-megawatt per second switching. Huge. You switch on within 10 microseconds of power of 5 megawatts module. And you have then a very well integrated data acquisition control system, wherein you go for acquisition rates which are in the range of megahertz in some channels, but generally in the range of few hundred to 100 kilohertz. All of these put together, we call it, and many others in the community and also in the Tokamak community call it. This is an engineering-wise an extremely complex challenge, and it is. It is a challenge to really get the whole thing functional because of the engineering, because of the challenges on the manufacturing. And we, in SST1, went for what is called a 1,000-second beam, which is essentially every component that sees the incidence of the beam is a steady state. It can remove that. So you have to have material engineering, you will have to have thermal engineering, you will have to have power supplies which conducively addresses to the needs. You will have to have the data acquisition, which also goes for a long data acquisition, long duration, storage, access. So it is a microcosm of Tokamak, we say. Other than the magnets of the superconducting size, this magnet is no less complex because this also has its fringe field. This also has its attributes in the form of what is called the saturation, magnetization, and all that, and you have to really configure the magnet. We did it incidentally. That this was done by Andrejit primarily in collaboration with RRCAT, and it was manufactured by Dan Physics. We couldn't find any Indian manufacturer for this. But as I said, our approach was we get the ion source because that's the complex technology which we didn't want to get into then because the industry was not capable at all of support. So we went for a direct order with prefer vacuum then in Germany. And then we tested the source because Professor Jones suggested at that point of time that if you bring the source here, that you would not know how well it operates. Even if you know the technology, why not go the other way around? You operate the source, you get all the parameters, and you bring it assured. That's what was done. We then initiated indigenous developments in 1991, collaborating with several Indian industries, completion of mechanical systems in 2005, power supply systems then was also developed and delivered by 2005, system integrated and test initiated by 2007. And in 2007, my assignment at the T&D was closed, and I was shifted to, or I moved over to the NNB and the ITER project, and this continues. Right now it is continuing with Prahlad. I think Ujjwal still has the overall command on this. Now, in this pursuit, we have gone through several developments of technologies and developments of a kind which are of the first of a kind in India for sure, but also some of the demonstrations have been first of a kind or at the first instance in the world. This one, that what you see here, this long-standing thing, cryopump. We talk these days about cryopump being developed only recently in ITR in the 2020s and all that. It's a matter of regret for me that in this organization, nobody has taken a recognition that the 3-meter cryocondensation pump, the cryopump, was developed way back in 2003 and tested in 4. And actually, I mean, the accolades and compliments on this certain tests were of a very different class and maturity. Yes, then we went into cryosorption pumps and other aspects. But then this is the organizational aspect. There are developments which are not recognized from group to group across, even within the system. This is one perspective which I think we need to really break the barriers and really go into a mode where we understand, appreciate, and communicate each other's progression appropriately. I will not leave any opportunity to bring out points which I think are hard, and I also took this. But what is important in this is, this was a pump which was interesting. We pumped deuterium, and you have to pump deuterium at around 4.5 Kelvin. So there are helium, transfer lines, doing everything. But what we did is, these pumps, one is the proof of demonstration of the engineering, proof of demonstration of the performance, but these pumps on the global scenario, they were all talking in terms of the safety limits. 12 torr-liter per liter is what is called the safety limit of the hydrogen retention in these pumps. So subject these pumps to more aggressive tests, get it to the safety limits, and then regenerate and see what happens with all kinds of precautions. This pump was taken to that, and that stands as one of the hallmark experiments, which in fact, as I later captured, that Chris Day and Matthias Dremel had actually come here, and they made a specific objective to have a discussion and also look into this pump and others. And today, of course, I know them, Matthias I know extremely well. So this is me. And then also there were many of these developments on the power supplies, which was not my domain as such at that point of time. For Robin, I did engage with Agrajit extensively in terms of power supplies. And then I used to, with him, I used to then expand on what I handled at that point of time, which was a pretty minuscule of what he has developed, Agrajit later. The power supplies were there. These are of the RHVPS kind. And then there were these large vessels of rectangular kind. These were not manufactured in India earlier, and these are not easy to design because you really have a lot of design considerations on the stiffness and others. But what is more important and gratifying is that these vessels, when they were designed and when they were manufactured, the first manufacturing, we wanted, I think, less than 4 millimeter or 5 millimeter of deflection. The exact number I don't remember, but I remember that when the vacuum pumping was done, 14 millimeters of deflections came up. So back to Godrej, what to do. So Godrej, then we discussed, and then Maleshwar Rao was there. He actually then went into the 3D modeling of this, and with the 3D modeling and SIS modeling, and then it was established that it needs to be heavily stiffened on more areas than what was originally provided. That was done, and that was done by Godrej, and it was done with no cost. So the other part of the development was that this hyper vapor truck. Now, here I think I need to speak about this more. Chandra's contribution on the development of the copper chromium zirconium material itself is known. Balasubramanian in NFTTC. I mean, maybe they have some issues with time, but with knowledge, you will not have a comparative knowledge, personnel with comparative knowledge around us in this, around the globe. And I say this with, responsibility. We discussed, we developed, and then we went through GTRE and several others, and finally got the set manufactured. I think at that point of time, we demonstrated the EBW with GTRE, and the final EBW of the ones we tested was at PVA, or the ones which you tested in Julie, that was PVA. Now, So the developed, because we didn't have electron beam welding machine in private sector. Now also we have very few. ASACO is one of them. Today they have developed one which is full capacity. Now the important point here is that, and this applies to any of the developments that at least I have been a part of. Any development you do, you establish the metric, you test it for the metric, you see it qualifies for all attributes that you need to really have it applied in the functionality. That's the way we did it, and this was exactly done. In fact, Chandra, in his test in KFA Jülich, went a step further. He actually drove it to a burnout. And then he has the data of, I think, 2.4 or 2.2 kilowatt per centimeter square, wherein under those flow conditions, this HT is supposed to have the max power loading, maybe up to 1.8 to 2, and cut off. So these are the kind of things that was done, and there are many, many other developments which were on these lines taken up. In the meanwhile, around 2006-07, I think Mainak and some others, maybe Vijit and others, they started experimenting. I think Jana was extensively involved in bringing up a prototype ion source so that the power supplies, which are essentially for the discharge and the filaments, they get kind of conditioned in this application, and this was tested. So this was also the journey which was going on. And on went several others. These essentially brought to light the fact that the system in its form is integrated, and then it, of course, has taken a reasonably long time to bring to this stage, which we presented in the review, and Prahlad, courtesy of Prahlad, that I have taken this slide, that this demonstration of operation was there, and of course this operation has to go much beyond and to demonstrate whatever is the mandated task of this. In talking about this, I think I cannot shy away from doing this very important perspective conveyed, that many aspects of my growth in the organization, apart from whatever I have said about my erstwhile project leaders and others, I attribute it to him, and it is really my tribute. He has been my friend, philosopher, guide, and the kind of relationship we had is of an amazing kind. Of course, beyond professional also it was there, but the professional, and professional means the appreciation of each other. I remember Professor Kaur once saying, Larry has become a fan of yours. I got embarrassed, but he did say that. Larry Grisham, the amazing part of it is, how did I get this whole thing? And this is one of the most memorable events of my whole spectrum. The first trip abroad from agar dena hai to black. Thank you. Thank you. It was in Lisbon. Soft, I had been there to present the conceptual design of the SST1 neutral beam. And in that, Larry saw the paper and he just started discussing. And see the way it unfolded. He found the approach interesting. And then he said, let's sit for a discussion. And it was a 4-hour long, just on the staircase, 2 of us sitting and discussing several aspects. The good part of that was that then in those days, I have a history of going back even today at 8:39, and even then around 8 o'clock, whatever was the last bus, sometimes 9 o'clock bus, it was from here. So till the time daylight in the summer, it was around 7:30. What I used to do is I used to smoke. But then I used to go up on the terrace and then take the file and read, understand. I somehow imbibed in me a complete understanding, a complete repository of what is practiced in neutral beam systems in each and every of them. And this is what essentially enabled a wonderful discussion with Larry. And Larry then conveyed several aspects of his experience back to me. Of course, he did also say about how the TFTR neutral beam integration had a problem, but that phase was much later for us, and we didn't have this phase here. And this is what essentially, one is I had got the confidence that yes, what I have thought through is right, and what is received, what has been received by me from you also is substantial. So the crystallization of NB system has essentially been enabled just that 1 4-hour discussion. And our interactions continued for long, and unfortunately fate snatched him away. And it is really tragic that Larry passed away, I would say early, out of carcinoma. Now, let me come to ITER. As I take science, technology, strategies, negotiations, contractual discussions, etc., and speak some parts of it, I take a pause. I take a pause because, and I need to convey this here, not from the perspective of I must, but from the perspective of I think there could be moments of this kind which comes to you. While I have made my sincerest contributions and growth and everything to the senior project leader, as I said, Professor Mathu, that some of us may have this understanding that there emerge differences and there can emerge differences with your leading. Of course, it's not that I did not try resolving, but then when I realized that the differences are expanding because of not him alone, but maybe associated aspects, I stopped. And this is a very, very sad and hard point for me. Because deep in me, I have my gratitude to what he has given in terms of the guidance and the growth that I have. I would not be standing here and talking in the way with the bandwidth that I'm talking or I talk. In fact, that's why people say about me. It's not to really say that they say, and so note this, but they say that the bandwidth is extremely wide. But they say this because I cultivated and I cultivated because of him, but you can have a hard point. This remains as a hard point. So as I go to ITER, I think this is a point which is a completely different perspective, and it is a perspective where the whole orientation of how I address to matters have changed. And here I must also say that I have discovered later also, in the organization, there is a need to have personnel, particularly at the helm, to be receptive to a kind that if there are issues of adequacy of which demands adequacy of seriousness, they get addressed also adequately with due. Otherwise, you drive demotivating factors within the organization. So this is one perspective, and this is where I said I'm not going to write it, but I'm saying this because of, and I know it is important. It is important. So, yesterday you presented, and what a marvelous presentation. And I can only say that just you did mention this, and it is indeed that based on I now go back to it. So the kind of scalability seen, the confinement improvement seen, the models being more and more conformal, the particle exhaust being more and more controllable, and disruptions being more and more studied and managed, different configurations of diverters being studied, and novel state of operational configurations and exhaust coming up. ITER was a natural corollary. It's a huge cost, so obviously it had to be done in a way. It also is a huge intellectual effort. So it has to be done in a way that involves multiplicity of efforts, and this was indeed the case. Of course, challenges on material, remote handling, tritium, and others would remain. So this is like a kind of a confidence build-up. This was the agreement. Yes, important. It is good because this kind of a talk can bring this up. So India joined in 2005, and the agreement was signed in 2006. And I mentioned this because I was a part of this team which was kind of assigned to Jeju, and Professor Kaur himself was there and others. The evening of this, I think I'm allowed to talk about what I'm talking now, even if it is a dry season. The evening of 2005, this date, December, I think it was December, write the date. That I think Vasu and myself went to Professor Kaur, we should celebrate. We should celebrate. How do we celebrate? Yeah, we should have the best possible champagne ever. And in Korea. So what do we do? Champagne, how do you get it here? You have to see. So Vasu, I'm an optimist by nature. So I said, Basu, let's go. And we really went, and we had to search a number of shops. And we really got champagne of France origin in Korea of the right kind, and the right kind of cheese that goes with it. and we bought a bottle of cognac. We had a wonderful celebration in the night, but then the nicest part of the anecdote was the cognac that was there. Professor Kao is a disciplinarian. So after the champagne and others, we have to call it a day, maybe a few sips of the cognac. And Professor John, how can we live without having, the right this thing of cognac, getting the cognac in the right extent? It was really so, I felt it hilarious, of course, but it was nice to capture the reactions at that point of time. So this was one thing. And so that celebration is what I remember much more than anything else. Must be, because this was the signing of the agreement. Must be, because this was the ITER. This is not where I was. This is not Jeju. This is Paris. This was the signing of the agreement. I just took the opportunity of not to increase the slide. It should. ITER goals we know, and I think after Shishir I don't need to repeat. The making of ITER, I think that part, I think some of us maybe still, if you are from IPR, may not be into it. We pay cash contribution to ITER. We pay hardware. We provide hardware to ITER. So we pay in kind, and we also provide the cash support, and we share the intellectual property, and the staff is from all across the member nations. India representation is low, but it is otherwise. And Europe provides buildings and other site support. He was mentioning about the site agreement yesterday. We have, for ITER, now this negotiations had a lot of precursor events. I do not know, I had to unfortunately leave your presentation earlier. Thank you very much. Your presentation earlier, Shishir, but I do not know if you talked about this. There were precursor, and apologies if you have, precursor activities. There were European delegations who came first, and there was also an ITER delegation then. And the ITER delegation went through also the European, but the ITER delegation I was associated, and they went through different industries, had assessments around the labs, and also the overall discussion that took place here. And the perspective that emerged is that India, of course, cryostat-like delivery, yes, and then in-wall shields and cooling water and the cryo lines, and then came the other system, Shimomura, who is unfortunately not there anymore. Shimomura was there taking round of the present NB lab, the RF facilities and others. He made a comment. It's not that he made a comment to me, but I just asked him that, how do you find it? He said that I see that IPR has a higher level of developments in the heating current wave systems as compared to the Tokamak operation. That's a comment he made. Now, I think these kind of also brought in within the ITER thing, what kind of things to allocate to India? What do India do? So out of all these were the hardwares, the systems that we have supplied. There is a lot of diagnostics responsibilities, and there are others. And some of the critical ones, particularly actually in the RF system, the EC system, the RCRH system, and then also the particle system, the DND. DND was something that was really, I think there was a resistance because UK AEA was very keen on this, and they were trying to go for the positive ion system, which I now get to understand, positive ion based system for the DND. But by that time it was taken over, and then they had this, this was already done. And Pietro, when he was here, I think in February he was here, he did say India did a very clever planning by taking this. So I would take a couple of examples to really say, and because of my trade, because of my association, I would definitely dwell more on DNB to really say that what we try to do in this. But I think there is a, yes, there are important questions that we need to address. And the important questions that we need to address are, Okay, you have joined ITER, and you have taken an extremely big leap, extraordinary leap. And we have not built a device of this kind, not this kind, of any reasonably sizable kind. We do not have an established QA/QC. We do not have a standardized documentation as applicable to this. We have not built any equipment based on nuclear codes. But how is it that we have organized ourselves to a structure that incorporates all the above and much beyond, integrating a large section of Indian industry and framework of delivery? This is not mine. 2005 onwards, I was associated with ITER, and today. And I would say that this is one point to look into. The second is also to look into whether or not this cell of ITR have matured within in having an engineering approach to the project, which I remember what I said earlier. A deep understanding of the QA/QC project management essentials, an approach to assess risks and opportunities while addressing to the requirements. In short, does it have a competence profile that matches with those existing among the ITER partners? I think today we have satisfaction in stating as a response, yes. And it is with this yes, I would say, as you see some of them, that the importance of integrating this experience that is now cultivated in a professional set of around 110-20 personnel to be widened up. Of course, in IPR, I would go beyond, even in many of the DAs. It is important that we propagate the practice of implementing projects. Well, every institute may have its own way, and every institute may stand by, yes, I have my way, who are you to tell me? But it's not just that. It is much beyond. It is basically also to say that we should see our project execution time. Don't park with the aspect that ITER has taken a long time. There are histories of delays in many other things. We have to see about the deliveries. We have to see the quality of the deliveries, the reliability of the deliveries, the monitoring of the deliveries. And therefore, this learning is important. And I think this is an asset that is for the nation in terms of having this cultivated within this ministry. And here, Shishir led it initially, Ujjwal leading it now. I think both of them deserve to be complemented in terms of enabling, in the spirit of what I said earlier, that IPR enables a reasonably free, horizon to develop, enabling a group of professionals to develop appropriately. DNB, I'm taking it, and I'm just basically trying to say that what was, we took this because we had interest in these, of course, and then we had to configure a way to do this. We had to configure a way, when we took the DNB, when we got assigned the DNB, there was no negative ion experience. Only perspective, which was Mainak had gone over to IPP during the PNB days itself to do some R&D work in Garking and on the RF source. That was a negative ion exposure. Beyond that, we didn't have any initiation. The accelerator community was doing minuscule levels of current. And there are, as I said, plethora of physics issues. So we had to do some kind of a leapfrog. These are the parameters for DNB, so let's not get into it. The leapfrogging was to be a strategy. And the strategy, again, initially, of course, contributed, but then contributed by Professor Mathu, but further primarily by me, and also enabled extensively by Mahendra, Mainak, and others, in terms of consolidating it. That is, we decided the best way to go about it, and that is important. The best way to go about it is harness what is available as a knowledge and also as an information and replicate it. Replicate it here in a manner that your team replicates it, your team operates it, your team takes the heart of the system, the source, from an identified supplier, but integrates all around and brings it to the operation that it is mandated for. This was the perspective, and this was successfully implemented as I would say as a model of what could be a very uh, reasonably balanced collaboration, because this was balanced because IPP did not charge the moon. At the same time, there was a reasonable amount of access, and teams had gone there to get themselves trained, exposed, participate, bring home, and go to the Robin lab if many of you have not seen it, and see the setups that are operational. Kaushal is in the lead of operation of that system, and there are many others who are into it. And my apologies if I do not name everybody, but it is just because it just comes into me as a, and incidentally, Gaurav Bansal also initiated the operations. Now, Mahendraji steers primarily the operation, but at the same time, Kaushal is one. But then that was not all. We had a much deeper or a broader perspective in it. We wanted to bleed through whole of the technology chain in here. And we wanted to crack each and every aspect of what applies to this system in a mode that prototyping, resolving technologies. Well, industry doesn't exist in India to do it. What can you do? We have held hands with, we have pleaded with L&T, take this. They did not. They did not quote. So fine, we had to go out. But we had to go out with our firm understanding, and today it is really something that the companies actually come back and compliment that these are the things which you have enabled in resilience. That's a knowledge built up. So this is what we did. So there was a technology roadmap, and many of this technology roadmap has been primarily steered by Jaideep and his colleagues. So much so that even the most difficult electrodeposition technology is done. Boom, RRCAD did. And fantastic, it's over, I think it is over about a meter in the width, or 80 centimeters in the width. I don't remember the dimension. It is, I think 80 centimeters, so about a meter. Width and 3 millimeters thickness, done. Technologies on welding, done. Technology on EV welding, done. Why did we do all this? We wanted to come to a stage that, and this is what I leave the system in a better state, that I can say that if the country needs, and if the industry enables, you can build this integrated. And that's, I think, a satisfaction. Of course, whether you can bleed through the physics, it is a different ballgame. So Robin essentially has produced extremely high quality beams of its own relevance. It has realized the ITER parameters of 30 milliamperes per centimeter square for hydrogen with the relevant metric of cesium consumption, multiple number of things. It has established the conditioning techniques, the cleaning techniques, the operational methodology, and it has gone beyond. And that was an experiment which I think Mandrajit and I think Kaushal did it in terms of magnet configuration. They changed the configuration and also got a map of a performance which actually demonstrates it even better in terms of its operation than IPP. And I do not have the report from NIPS of today, but I know that this has been essentially presented in NIPS, and there was a lot of also discussions. And I believe, because I was not at all there, but I believe that NIPS did have an appreciation of this. This is something which is important for all of us to know. 2007, the licensure agreement gets signed. 2014, the beams gets operational. And over these 10 years, it is a history of reasonably sound, solid database on these kind of beams. If we could replicate, and I have not been able to replicate this in the twin source, unfortunately. Though I have taken this up as a project of an indigenous development with a dream of having a two-driver source operational, that's a hard point for me. That I could not get this operational in the mode it was. I hope this is getting addressed appropriately later. So the key accomplishments that I was saying is that the twin source, the grid holders, and etc. These are things which you can actually go and see in the lab. But the much bigger one was that when this group in the DNB actually, after receiving the components, and these are ITER components. This is a ITER neutralizer. This is a ITER residual ion dump. This is not a ITER calorimeter today, but maybe tomorrow we will try it. But the group commissioned all of them with within a record time and very, very methodical approach, which essentially replicates that of ITER. And not only that, it is much more important to say, I would, if I were in ITER, I would have given this as an example to ITER as to how you should be actually taking your systems rather than, going about it in the way that you plan. You can see the calorimeter movement mechanism. This was a design which Hitesh Patel helped with. I think Rupesh also initiated it, and it is working, and it is working perfectly. There were several challenges which are coming up on our way, and we are still addressing them on the source, but I think we see a better horizon down the day because the beam source is also an ITER component. All that you see is an ITER component. And what you see here is essentially a kind of plasma box with a backplate with a Faraday shield incorporated. Again on the technologies, the large quantity of the, these were the learning phases where in 2012, 14, we bled through with NFTDC all the technologies. And what a level of confidence that we have today. The nature of things that really brings up here is one good example of aggressive, I would say, aggressive decision making. We went for cryosorption pumps now for the INTA. And while we were doing this, I wanted to steer off from the helium refrigerator system. And when I wanted to steer off, I said I will do the cooling with a cryo cooler. When we took this, I was having a bit of an apprehension, but then there were calculations to back me up. And wonderfully, opportunity, that's a recent opportunity. So Chakraborty came for a suggestion on what to do. I think Ujjwal asked me that there is a problem on the cryo system. I said, you take this and you get it tested in your system. It is another matter that this is not utilized or applied today in the TNB system, but very recently, 2023 only, or 24, 24 itself. And this was a test which essentially demonstrated the performance of this pump and the cooling with one single cryo cooler, the whole cryo pump. And that essentially validates the concept of what I said, that aggressive engineering decision making, which we should do. We should really get into that kind of frameworks. We did a lot of improvisations on many of these, and these are, why am I showing these? These are elements which has given me enormous amount of satisfaction in terms of what I carry home with, in terms of, when one goes back, you always try to think that, and these are all individually, each of them, I do not interfere, like I have learned from Matur not to interfere directly into the system. Independence is what you should. But at the same time, you have to have established, and that's what is, if I will say later, is what you need to establish, that how to follow up in a matter that is closely monitoring otherwise. So these are things which have been done by industry. I have one or two meetings and that's it. But then Viraj, Ravi and others, laser cladding, porcelain insulator, these were never earlier there with us. So all these prototyping experiences, and now we are getting, with wonderful support from Larsen Tubro valve, this stage that we are making this valve in the cryolines. Why am I showing the cryolines? The cryolines also in ITER, because Raj was asking about how we went about ITER. When you have very complex systems in ITER, we took this, that if only one company is in the horizon, think of multiple. They actually went for two companies, and one was Inox India. And today, what a success story we have about Inox India. All the credits, of course, goes to the cryogenics team. But then, with this, they have essentially established them in such a way that today they are competing with Dimaco, we went with Air Liquid and others, and they also are getting the contracts, and sometimes they lose it because of the high price. But they do get it. Ion cyclotron also did the same thing. ICRH went for Thales as well as CEC to do the benchmarking and testing, and then the whole development. Today, we know this. So there was a comparison of the outcome, and ECRH also did the same thing. They developed a test stand, they demonstrated the gyrotron, and to really cultivate the learning of how to operate the system. High voltage power supplies, the story is very well known. There is an extremely high level competence within the organization on this, and all high voltage power supplies for Indian deliveries, as well as some of the Japanese gyrotrons, maybe some of the European gyrotrons, and also we are foraying now into more of the IC systems, high voltage supplies. They will be here. Diagnostics, there's a large number of diagnostics, and these diagnostics are listed as X-ray or the charge exchange or the DC, but The challenge is actually integrating diagnostics in this kind of a structure, which is in a nuclear device. Here is the nuclear interference that you really get. You get a port plug with a diagnostic design which has to really map the neutron dose rate at the end with a very stringent condition, and this is where your whole diagnostic positioning alignment skills come up. There are several patents, many from the DNV, but also from the IOF, from the cryogenics group, and there is a huge canvas of industry, and I think industry and us have integrated extremely well, and that is again another satisfaction. ITER would not provide solution to everything, and this is already provided by Shishir, that you need further, you need on the materials, you need on the test blanket, you need remote handling. Let's go later. For me personally, as SRPC chair, I'm changing the topic now, I have a good, what is like, I try to bring a difference in the way we review our person. And that, I think, is today followed, and I am happy about it. As the purchase chair, I tried bringing in a rationale of facilitation, and only as a facilitation. If rules are there to guide you, rules are there to govern you, rules are also there when you are in a constraint, you know how to really bring out the right notes and have your justification embedded. I tried all this. I do not know whether in purchase this is still a methodology. And many several procurement committees said, and there were roles as facilitators. And as a lead person in MAC, ITER MAC, I think my contribution has primarily been to position the Indian perspective, mostly on the procurement, and they really now, I would say, respect the Indian view on this, which is important, that there is a kind of understanding established. And also I have tried every mode to try and see that the Indian industries get into contracts. Now, this Raju allowed me. This is very important, though it is the end. Going to be. Have ambitions, please, must be. But do not put the ethics in the right bucket. They have to go hand in hand. Do have the practice of acknowledging whenever it applies. Nothing is to be considered as obvious. Apply rationale, keep your vision clear, always into the minutest detail. Always remember, leadership does not need to have a kind of association with seniority. It is an individual's ability to accept accountability, lead teamwork, provide scientific and technical guidance that matters most. For those dealing with contracts, remember, vendor or contractor is your partner. He needs to have your confidence, and the more you engage appropriately, the more he commits. Further, please remain discreet with your contracts as well as contractors, and keep that professional hat on when you deal with them. But never ever get into a kind of, you are supposed to serve. It will not. Never refrain from expressing your honest scientific technical assessment judgment when asked for. Yes, you may have to pay a price. This may lead you to being sidelined, but you would have done a great service to science for which you are here, and your pay is not going to be reduced. And do not worry, if your foundations remain right, time would not be trivial. Refrain from brushing issues under the carpet. Remember, someday the dust of issues will pollute, and someday you will not be able to even remove the carpet. Then what happens? Learning has no hierarchy. Never ever ignore alerts. Assess, address as per assessment. Leaders need to listen to the concern at the lowest level. Avoid conveying unpleasant notes to colleagues in a group. Do so in private, but within professional norms. Even in private. Do not bury conflicts, please resolve them. Else they grow and corrode the edifice of the group. Small conflicts in centers, if you have just ignored a conflict, remember it is going to corrode the overall system of your group and then the system at large. Always give the attribute of accepting any miss. Own up. Say, I could not. No problem of that. But do not find a scapegoat even if you do not know. That is unethical. And that is what I meant by the first one. In a group discussion, It is important to have your content noted, not your voice. So make sure you position your statements, whatever observation, in a way when it is merited and when it is to be noted. Just do not speak when others are also speaking. If you have a louder voice, you may be just your voice is onto the ears, but it has no sense. Most important, establish or practice transparent information sharing. This applies to technical and administrative matters as well, where unless there is a management or administrative diktat or kind of you have been conveyed to remain discreet. Do not make a very junior colleague feel that I am out of the information feature. You do not motivate people in that way by retaining information. Your bag will be full and it will burst out and you will not be able to contain them. Please take care of these things. If you wish to, my experience I am sharing with you in terms of trying to be a professional, I cannot say anything more. What has been gratifying for me? The learning experience with Professor Mattu in the earlier phase has been an extremely enriching experience. As I said, I had the freedom to explore areas and I owe it. The realization of several technologies on the cryo, on the copper zirconium, on the vessels and full spectrum of neutral beam technology, as a part of the DPR of the fusion technology also, it's gratifying. It is gratifying that how we could set up the licentiate agreement with ITT and Robin, etc. And also the dedication that I have seen displayed by the DNB team in bringing up the kind of integration of. I am also happy about the extremely complex, and this is my personal effort in resolving extremely complex contractual complexities for ITER-India's contracts on cryolines and cryo distribution. The role of MAC in ITER, I think an effort in positioning, the reception of relevance of Indian industries is also a matter of gratification. And that is because of the fact that today I see that they are really receiving contracts of substance. The substance means even to the extent of getting right into the machine integration. That's the second point also. The recent initiation within the organization of a candid framework on where we should be, that is what I was saying about graduate initiative. What should be the role of SST1 and how to integrate experience from ITER in the making of SSH? Happy about it. What do I leave behind? I leave behind experimental setups. I leave behind a number of professionals trained with requisite expertise in their domain, and this has been one of the most important perspective of me. As you would have realized by seeing the profile, I think within the 4th or 5th or 6th year of my induction, 5th year of induction, I went to the group leader and so on, stayed on to those levels, but then that's what essentially started configuring. It's called mentoring. I tried that. And I tried that, and I'm happy that I do see reasonably, you will not be able to mentor 100%. If you are able to mentor even 25%, be happy. You have achieved. Maybe I should say, if others are excellent, they can maybe more. Number of industries who have now matured to address several complex requirements and would be willing to partner us in our next mission. I live behind that. A number of publications, quite a few of which could be providing reasonable basis to design, install, and operate complex systems. One of the things which I think one of the discussions Mr. Shiv was also saying me that the publication that came out from ITER-India, okay, I was the first author because I made the overview presentation in FEC, but in the nuclear fusion. This was fresh from the oven, all the slides, so this one I could not just go back to the mail and track that the nuclear fusion the details, so I did not put that. For ITER, I think I have a very, very important role. This Pietro, I mean, DG ITER had asked for me in 2022 November when he heard me in MAC. He asked me, can you address to the development of a technical quality culture improvement in the organization? I did it, and I not only did it, I made a dossier which is a report and a set of recommendations. What I'm happy about and what I'm leaving behind is to basically, I'm happy about the fact that ITER organization is actually implementing several aspects of this one by one, very nicely in the system. And this, I leave behind that this transition is gradually happening within the organization. And I leave behind the best wishes for this organization to reach the pinnacle of glory in fusion and fusion technology. Thank you.
Thank you, Arun, for a very fantastic talk, and also putting some bitter issues, little bit bitter issues, you can say that. In fact, we want that, honestly speaking. When we propose to start this type of talks from our superintending officials, it was our idea that if you feel that something should be improved upon, because you have spent around decades of time in IPR, so you can say those issues. You can express those things that IPR needs these improvements, and the coming generation, I hope, will take it in a positive way. In fact, there is a proverb in our scientific history that you come to your organizations with your mind, keep your heart at your home, enjoy it after 6:30 reaching home. But when you come to your office, come your only blunt mind, है ना? दिमाग को यहाँ पे लेके आओ, दिल को घर पे रख के आओ, एक्चुअली बाद में शाम को जाके उसको बात करो. So because
जिनका दिल इधर है वो क्या
So hope you people will learn lot many things out of these 3 talks, very important talks, and from a very experienced, very senior person, and hope you will take these things in a positive way. There is a proverb now that if you go for an argument, हमारे होते रहते मीटिंग में आर्ग्यूमेंट होते थे, if you go for an argument, take care of your temper. Your logic, if you have any, will take care of itself. आपको खाली अपने गुस्से पे कंट्रोल करना है. लॉजिक तो माइंड कर लेगा, उसमें कोई प्रॉब्लम, वो अपने आप देख लेगा. आपको खाली अपना जो द वे यू एक्सप्रेस, सम टाइम मैं देखता हूँ झगड़ा कर ले, जरूरत नहीं है उसकी. तो पढ़े लिखे आदमी आप शांति से भी अपनी बात कह सकते हो. और कुछ लोग देखे, मैं आपको एक एग्जांपल देता हूँ, नाम ले सकता हूँ, अच्छी बात है. शाहू को देखा है मैंने, आया क्या यहाँ पे? बंदा अपनी बात से हटेगा, एक्चुअली अड़ जाएगा उसके, और उसके चेहरे पे आपको बिल्कुल सिकड़ नहीं दिखाई देगी. इनफैक्ट शशांक साहब ने मेरे को एक बार बताई, ये बात बताई, बोला राज सिंह यार जाता ही नहीं. मैं बोलता जाओ यार, तुम निकलो ऑफिस से, निकलता ही नहीं है, अपनी बात मनवा के जाता है. तो दैट्स द साइंटिफिक वे ऑफ एक्सप्रेसिंग दैट our views. So thank you, Arun, really much thanks, very sincere thanks. Now I'll Mukherjee to present a moment to Arun.